well. Okay, so let's build our spreadsheet. So let's focus in here, guys, and let's build this spreadsheet. So what do we need to put into our spreadsheet to do our pump test on this data? There's lots of different things we're going to need, but can we start with the volume, and then we're going to do time, and then we'll do flow. Okay, and this will be in GPM. So our volume is going to be in gallons. Okay, our time is going to be in seconds. And then let's actually do another time. So let's insert in a new column and do the time in minutes. I'm going to go pretty quick here because I'm recording and because I want to get to the review. So, but you'll have this afterwards. If you can keep up, that's great. What was our volume for all the different measurements we just made? Yeah, it's 1 quart. So I'm going to do it in gallons. So it's just 0.25. And how many different measurements did we make? I think we made 5, right? Okay. Now let's just do our times. So what was the first time? 34. And then 22. Yep. Yep. And 11. Okay. That all makes sense. Can we convert that to minutes? Yeah. How would we convert those times to minutes? Yeah, just divide that guy by 60. Oops. So divided by 60. Okay. Pull that guy down. Now, how do we calculate flow? Flow is in gallons per minute. So we have gallons, we have minutes. What does the per mean? The per means divide by, right? The flow is equal to the gallons divided by the minutes. And I'm going to clean this up a little bit with some few less decimal points here. Okay. And now we can drag that down. So now we have our flows. And we have, what else did we measure? We measured the pumping elevation or the elevation head, 4.5. We missed one here, guys, right? The first measurement, 0.25, was a no flow, right? And what was the height? That was the 4.5, wasn't it? Or was it? Is that right? That was the 4.5. I think the first one we actually measured was 4. And then it was 3, and then 2, and then 1. So why do I have and then 0? Maybe it was like maybe a half-ish. Yeah. Okay. All right. So this is going to be in feet. All right. Now let's talk about HP, which is the pressure head. Where I was measuring flow, what was the pressure head? You remember where I was measuring flow? It was coming out of that pipe, right? Was there any pressure head? It's open to the atmosphere. You see, so my pressure head the whole time was 0 actually, because I was actually moving where I was measuring my flow along with my pipe there. Is that clear to everybody? The pressure head 0. Okay, so my pressure head 0 the whole time. What about my velocity head? And in fact, what I'm going to do is I'm going to insert a couple more columns over here, because for velocity head, what do we need to know to get velocity head? We got to know our velocity to start with. Exactly, and for our velocity, we have to know our inner diameter, okay? So let's do a velocity calculation. So let's do V, and that's going to be in, say, feet per second. And what's our equation for velocity? 0.408 times the flow in gallons per minute, right? So that one divided by inner diameter squared. Very good. What is the inner diameter of this guy? Honestly, I think it's 5/16. Yeah, if anybody has a ruler, I would take it, but otherwise, I'm going with 5/16 of an inch. So how would we put that in here? 5/16. And then what do we need to do to that 5/16? We need to square it. Okay? I think this equation should be right. We have our coefficient, the 0.408. Then we have our flow, D2, divided by our ID, which is that 5/16 squared. Now, Another way that I was telling you to do this right is to put your constants up at the top. This is a best practice. So we would have our ID, that's going to be equal to 5 divided by 16, and that's in inches. Okay, so now what I can do is I can change this formula, and I can say, look, instead of this 5/16 being in my formula, I can say that diameter. And what do I want to do? There's one step here. I need to lock it, and the keystroke for that is this F4. So now it's locked. Okay, great. Copy this down. Does this all make sense? These velocities? They seem reasonable to me. Just based on how fast it looked like it was coming out, somewhere between 2 and 5 feet per second, seems pretty reasonable. All right, so how can I use that velocity now to calculate my velocity head? What's our equation? We're close. There is a 2, there is a g, and there is a v. V squared over 2g. Okay. I know that not everybody has these equations memorized, but this is a good one to know. V squared over 2g. This is my velocity head. Okay. So where's my v? Well, that's here. So v squared divided by, now the 2 and the g are in the denominator, right? So what do I need to do here to make sure that I divide by both of them? I can use some parentheses, right? So 2 times g. Okay. Now again, g, I'm going to put up here in my constants right there. And that whole thing is, but right now I don't have g there. And what is g, by the way? 32.2, and that's feet per second squared. All right. All right, so let's drag that down. Oh, what did I do wrong? Why is it not working? Why am I getting errors? I didn't lock it. I did not do that on purpose, but it's a great example of a mistake. I should have said that I did it on purpose. You wouldn't have known. Okay, so there's my velocity head. Do these numbers make sense? Yeah, seems pretty reasonable. Can I calculate my TDH? What is my TDH? Total dynamic head, right? And it's the sum of all my 3 other forms of head: my velocity, my elevation, and my pressure. Okay, so this is pretty easy to do here in Excel. I can just say it's my velocity plus my elevation plus my pressure. And I can pull that guy down. Okay. What are some things that I'm missing? What do I still need to finish this off? Okay, that's a good question. Friction is a very important topic, but for a pump test, it's not something actually we're interested in. We're interested for designs of system, but I need my input power, right? My input power. Okay, let's do it in watts at first, and then let's do input power in kilowatts. All right, so what was it in watts? It was 13.6, you said, and then it was 14, pretty much. Is that right, Justin? You were our watt guy. Was it? It was, jumped up to 14. Okay, well let's just call it even here at 14, and then let's call it 13.4 at 0. Okay, so what does that mean in terms of kilowatts? This is in watts. So how do I convert kilowatts? Yeah, so I'm going to take this guy and divide by 1,000. All right, and then I'm going to drag that down. Okay. Now, I need to convert that to a horsepower, right? So how do I convert this to an input horsepower, IHP in horsepower? Awesome. You guys got this. Okay, so that's my horsepower. There's 2 more calculations as far as I can tell that we need to do. One of them is to calculate the water horsepower, right? And the other one is to calculate our efficiency. So then we're ready to go. So water horsepower. What is water horsepower? It's Q times my total head, which is that guy, divided by 3960. Okay, makes sense. There's 0 when it's not flowing. Very low horsepowers, of course. And the moment of truth, my efficiency. What is my efficiency? Remember, efficiency is always what I get out over what I had to put in. So what am I getting out here? It's the water horsepower. What did I put in? That input horsepower. So it's the water horsepower divided by the input horsepower. Okay. All right. Can we make these percentages here? Wow. That's pretty terrible. So these I don't know, I think I showed you the inside of Roger here. The first class is just a whole bunch of flat paddle wheels, right? So it's not even like a properly designed propeller or anything. So anybody with fountains and aquariums and stuff is just like 97% of that energy is just being wasted. So it's pretty bad, but it's still only 14 watts, right? It's a very small amount of energy. Okay. Does everybody feel good about this? I'm doing it right now. Yeah. That's why I was going a little bit fast. So I'm going to share this with you guys. Yeah. And then we're going to do the audio and the screen. Okay. So any other questions before I stop the recording? Go for it. All right. We didn't want that to be on air, but okay. All right. I'm going to pause this then.